Now that we've talked about parallel vectors, we can talk about perpendicular vectors. In terms of vectors, we call those orthogonal, and we do actually call them orthogonal whether or not they're in 2 dimensions or 3 dimensions, or doesn't matter. So we can use the dot product to determine if 2 vectors are perpendicular, and this is actually much easier to use with dot product, whereas in parallel vectors it was easier to just see whether one was the multiple of the other. Orthogonal vectors, the easiest way to determine whether 2 vectors are orthogonal is to find the dot product. Why? Because we know theta in the case of orthogonal vectors and perpendicular vectors, theta is 90 degrees. Cosine of 90 degrees, and this is why it's going to be easy, cosine of 90 degrees, well, that's 0. Because that's 0, and we have something being multiplied by it, what do you think the dot product of 2 orthogonal vectors is going to be? That's right, it's going to be 0. So if you find the dot product of 2 vectors and your answer is 0, you can conclude that the vectors are orthogonal. All right? So it's fairly easy to use. In fact, we'd love it if they were orthogonal. We had that on the first page in example 1. The third problem in example 1, you got a 0 for the dot product, and that was because those vectors were orthogonal. So determine whether the given vectors are orthogonal, sketch the vectors so you can confirm for yourself whether or not they are. So to do this, we just want to do the dot product. And we know that they're going to be orthogonal if our answer is 0. So 2 times 9 plus negative 6 times 3. So 18 minus 18, and that's 0. So yes, they're orthogonal. So to sketch the vectors, I have 2, negative 6, 2, negative 6. And so that's vector u. And I have 9, 3. 9, 3, that's vector v. And you can see it pretty much looks like a right angle between these two. And we've confirmed that it is. Okay? So go ahead and try example B and pause the video if that's what you're doing, and I'm going to go ahead and solve it. Okay, so hopefully you've tried it now. What you're going to do is you're going to find the dot product. 1/2 times 10 plus 5 times negative 1. So 5 minus 5, that's 0. So yes, these 2 vectors are orthogonal as well. So vector u at 1/2 I plus 5j is right here. So that's vector u. And vector v is at 10, negative 1. That's right here. And again, I can see these being orthogonal. And we've confirmed it with our calculation. All right, nice job, guys.